Students, this is your chemistry miss. In last class, we discussed about periodic classification of element. In that lesson, we learned periodic table, that is classification of elements, Daubinier, Mendeleev, Moser, modern periodic lab. Then next, periodic trends in properties, atomic radius, ionic radius, ionization energy, electronegativity, etc. In today's class, we pass on to the next lesson, alkali and alkaline earth metals. S block elements, the element belonging to the group 1 and 2 in the modern periodic table. Modern periodic table are called S block elements. We know the periodic table column. The left hand side present the S block element and right hand side P block element. So left hand side has a two groups. The first group and second group is called as a S block elements. Okay, the element belonging to these two groups are commonly known as alkali and alkaline earth metals. So the element belong to two groups. The first group is called as a alkali and second group is called as a alkaline. This is a periodic table. The S block present the left hand side of the periodic table. It consists of the two groups. The first group is called as a alkali. Then that is present the elements lithium, sodium, potassium, rubidium, cesium, francium, and the second group is called as a alkaline, beryllium, magnesium, calcium, strontium, radium, etc. So the first group is called as a alkali, the second group is called as a alkaline earth metals. In this unit, we study these properties. Unit uses important compounds and biological importance. First, alkali metals. First, we discuss about alkali metals. The word alkali is derived from the word alkali, meaning the plant ashes, referring to the original source of a alkaline substance. So a water extract of burnt plant ashes called potash contain mainly potassium carbonate. So the ஒரு பிளான்ட்டை பேர்ன் பண்ணும்போது அதில் இருக்க வாட்டர்லாம் நமக்கு போகிடும். ஸோ அதில் என்ன இருக்குன்னு பார்த்தீங்கன்னா பொட்டாஷ், த மெயின்லி கால் பொட்டாசியம் கார்பனேட். ஓகே, ஸோ the alkali metal group consists of the elements. The alkali metal groupல என்னென்ன எலிமெண்ட்ஸ்லாம் இருக்குது அப்படின்னு பார்த்தீங்கன்னா sodium, lithium, that is lithium is the first element of the alkali group. So the alkali elements lithium, sodium, potassium, rubidium and cesium and francium. Okay, so they are all are metals. So the first alkali metals contains all are metals. Generally it's a soft. So these metals contain generally is very soft and highly reactive. So they form oxide and hydroxide. So the lithium form lithium oxide, then sodium form sodium oxide, then sodium hydroxide, lithium hydroxide. Okay, so these compounds are basic in nature. These compounds are basic nature. So the acid react with the base to give salt. We know the point. So the basic in nature means it dissolve in water. So it dissolve in water means it's converted into OH. It converted into OH minus ions. So that is called as a basic in nature. Okay. The next topic is general characteristic of alkali metals. So the alkali metals are highly reactive. Alkali metals are highly reactive. Are found in nature only as compounds. Rubidium and cesium are found associated minute quantities with the mineral of other alkali metals. So here the lithium, sodium, potassium, rubidium, cesium and francium all are alkali metal. The rubidium and cesium, the last rubidium and cesium found a very minute quantity with the minerals of other alkali metal. Then last one, francium is a radioactivity, does not occur appreciable in nature. So it is a highly radioactive. It's a off life only the 21 minutes. Francium off life is only 21 minutes. So here the abundance of important alkali metals and their sources listed below. So the lithium elements, the abundance in earth crust 0.0018, the relative abundance 35. So the mineral source of the lithium LiAlSO3. Okay, so this is a lithium Li, this is a lithium Li, lithium mineral source is a sobromine LiAlSiO3. It is a transcoolant. Okay, so the next, the sodium, the abundance in earth crust 2.27, then relative 7, it is a rock salt. It is called as a rock salt. It is a mineral salt, is a rock salt. The rock salt is called as a NaCl. Okay, NaCl. This is a rock salt. Okay, this is a rock salt. So called as a NaCl. Okay. The next one, potassium. The abundance earth is 1.84. The relative abundance 8. The main source, or that is a mineral source of the potassium is a KCl. Potassium. This is a potassium chloride. Okay. The next one, rubidium. The rubidium, the abundance in earth is 0.0078. The relative abundance is 23. So it is a non-convenient source. It is obtained lithium processing byproduct. It obtained lithium processing byproduct. The cesium also obtained lithium processing byproduct. Okay. So lithium, that is lithium, sodium, potassium, all are stored under a oil. So the alkali metals, lithium, sodium, potassium are stored in a oil. Okay. The next one, the electronic configuration of alkali metals. The general valential electronic configuration of alkali metal is NS1, because the lithium, take the example lithium, the atomic number of lithium is a 3. So we can write the electronic configuration 1s2, 2s1. This 2s1, NS1. Okay. So the outermost valence cells all contain S1, 2. Then next one, potassium. The atomic number is a 19. So we can write 1s2, 2s2, 2p6. Totally how many? 2 plus 2, 4, 4 plus 6, 10. Then we know the half-hour principle, how to write. They will start with the least energy, ending with the 1s2 start panni 7s la mudiyum. We know the half-hour principle, how to write the electronic configuration. Already we discussed it. Second lesson, quantum mechanical model of atom. So the potassium number of the potassium atomic number is a 19. So we can write the electronic configuration 1s2, 2s2, 2p6, then 3s2, 3p6. You count the number, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, then 3s1. So totally 3p6, 7, 9, 10, 11, 13, 19. Okay. So the outermost valence shell of alkali metal is Ns. The valence shell electronic configuration of alkali metal is Ns1, where N is represent here period number. We know the periodic table period number 1 to 7 is called as a period number. Okay. So the here the electronic configuration of alkali metal table here, element, the lithium, sodium, potassium, rubidium, cesium and francium. The symbol of this element, lithium is a Li, sodium is a Na, potassium is a K, rubidium Rb, cesium Cs, francium Fr. Okay. Then atomic number for alkali metals 3, 11, 19, 37, 55, 87. So the electronic configuration, lithium. So lithium, it attained the one valence electron, so attained the noble gas of helium. So sodium, it attained the noble gas of 11, that is atomic number is 11. So the neon 3s1. Then potassium, argon 4s1. This is the electronic configuration of alkali metal. Okay. The next one, common oxidation state. So all these elements are highly electropositive in nature. They really lose their electron to give monovalent cation, that is M+. Alkali metals have only one oxidation state, which is +1. That is, all the elements are highly electropositive nature. So the alkali metals all are highly electropositive. Positive means they carrying the plus electropositive nature. They really lose the valency electron to give monovalent cation, that is M+. For example, lithium. So lithium, the atomic number of lithium is 3. So the electronic configuration is 1s2, 2s1. Okay. It loses one electron, the lithium carrying the plus charge. So the really lose the valence electron. Valence electron or outermost valence electron lose பண்ணும்போது it getting the positive charge. So that is called as a monovalent, that is a M+ cation. Okay. Then another one example, sodium. The atomic number of sodium is 11. So we can write 1s2, 2s2, 2p6, then 3s1. So remove the outermost valence shell electron. So the remove the one electron. So the sodium getting positive charge. So that is called as a monovalent cations. Okay, monovalent cation. Cation means it getting the positive charge. So alkali metals have only one oxidation state, that is a +1. The oxidation state of alkali metal is a +1. Okay. The next one, next topic is atomic and ionic radii. be the first element of the each period. First element of the each period, for example, the alkali element, the first element, alkali period, the alkali group, the first element is a lithium. Okay, then alkaline, the first element is a beryllium. Okay, the p block element, the first element is a 13th family is a carbon. So on. The first element of each period, alkali metal has the largest atomic and ionic radii in the respective periods. So the atomic and ionic radii in the respective periods, the alkali metals of the largest atomic and ionic radii in the respective periods. Okay. And moving down the group means lithium to francium. The alkali group la mele irundhu keela varudhu, we call as a moving down the group. There is an increase in number of, note the point clearly, and moving down the group there is an increase in number of shells, therefore atomic and ionic radii increases. What is that? So they are moving down the group la increase the number of shells, therefore the atomic and ionic radii increases. The monovalent ions M plus are smaller than the respective parent atom as expected. What is that? For example, lithium. So lithium, the atomic number we know. So first shell it contains 2 electrons. The outer shell is contain 1 electron. Okay. The next one. So it has only 2 shells. For example, then next one, sodium. Sodium first contain 2 electrons. Then first then 2. Then next 8. Then next third shell contain 1 electron. Then if compared to the lithium and sodium, it is a number of shells increasing the number. Here the 2 shells, here the 3 shells. Then potassium, first shell contain 2, then 8, then last one is it. So number of shell increases as we move down the group. The number of shell increases. So therefore the atomic and ionic radii increases. Okay. So the monovalent ion M plus are smaller than respective parent atom as expected. Here the physical properties of alkali metal are listed in the table. So the physical properties, what are the atomic radius, ionic radius, melting point, boiling point, first ionization enthalpy, electronegativity, density, standard electrode potential, hydration enthalpy. Okay. So the alkali groups are the lithium, sodium, potassium, rubidium, cesium. First the atomic radius, lithium to cesium, the atomic radius increases. Then ionic radii also lithium to cesium increases. Melting point, then boiling point. Okay. So listed in the table. The next topic is ionization enthalpy. What is the next topic? Ionization enthalpy. So the alkali metals have the lowest ionization enthalpy compared to the other element present in the respective period. Okay. So as we move down the group, the ionization enthalpy decreases due to the increase in atomic size. Ionization energy or ionization enthalpy already we discussed in previous lesson. So ionization enthalpy decrease ஆகும்போது due to increase in atomic size, the ionization enthalpy is decreases. So in addition of number of shell also increases, which in turn increase the magnitude of screening effect. So the ionization enthalpy decrease down the group. So just now we discussed about now to number of shells increases, the atomic and ionic radius or increases அப்படின்றத பார்த்தோம். So the ionization enthalpy decreases due to the increase in atomic size. In addition, number of shells also increases, which in turn increase the magnitude of the screening effect. Screening na additional அங்கே electrons அந்த வந்து add ஆகிறதுல ஒரு screening effect இருக்கும். So the ionization enthalpy decrease and down the group. So the second, compared to the first ionization enthalpy and second ionization enthalpy, the second ionization enthalpy of alkali metals are very high. The removal of electron from the alkali metal gives monovalent cation having the stable electronic configuration is similar to the noble gas. Therefore, it becomes very difficult to remove the second electron from the stable configurations it already attained. That means, so lithium, the atomic number is 3. So the electronic, the 2 electrons it contains, then the second is 1 electron. The electronic configuration 1s2 2s1. So that it remove the 1 electron, that is outermost valence electron remove, the lithium getting the Li plus. So it attains the stable electronic configuration for is near to the helium. So helium say 1s2. Okay. Then next one, sodium. The sodium Sodium's atomic number is 11. So it outermost valence electron remove. So it attain getting the Na plus. So it is 10. The 10 means the neon is 10. So it attained to the noble gas configuration. The removal of electron from the alkali metal, it gives monovalent cation having stable electronic configuration is similar to the what? Noble gas. Helium is a noble gas. Okay. So அப்போ சோடியம்லேருந்து ஒரு எலக்ட்ரான்ஸை ரிமூவ் பண்ணும்போது இட் கெட்டிங் பாசிட்டிவ் சார்ஜ் இட் அட்டைன் அது எதுக்கு இதுவாக அதுக்கு பார்த்தீங்கன்னா இட்ஸ் சிம்லர் டு எதை மாதிரி இருக்குது அப்போ இட் ஏதோ சோடியம் கெட்டிங் த 10 இந்த வேறு எதுக்கு நமக்கு 10ன்னு பார்த்தீங்கன்னா the neon is getting 10. So similar to the noble gas. ஓகேவா. So the next topic is hydration enthalpy. Okay, hydration enthalpy. So the lithium salts are more soluble than salts of other metal of the group 1. So the group 1 elements contain lithium, sodium, potassium, rubidium, cesium and francium. Okay, we know that. In lithium salts are more soluble. Lithium salts பார்த்தீங்கன்னா compared to the other பார்த்தீங்கன்னா the lithium உடைய solubility எப்படி இருக்குனாக்கா ரொம்ப அதிகமாக இருக்கும் compared to the as we move down the group. The high solubility of lithium salt because the small size of the lithium is easily solvated compared to the other. So this is a size. So lithium, sodium, potassium, rubidium, cesium compared to the lithium group, that is a alkali metal group, the size of the lithium is a very small. So it is a more solubility nature. Okay. So the lithium salts is a more soluble than other group of metal. Example LiCO4 is a 12 times more soluble than sodium Cl4, then potassium Cl4, then rubidium and cesium. Okay. So I have solubility only 10 power minus 3 times of that of LiCl4. Okay. இதெல்லாம் பார்த்தீங்கன்னா 10 power minus 3 times of that of LiCl4. So the high solubility of lithium salt, solubility nature வந்து அதிகமாக இருக்கும்போது strong solvation of the small size. எதனால் நடக்கும்ன்றாங்க அந்த solubility? The size of the lithium is a small. Okay. Then next topic is electronegativity. What is meant by electronegativity? Electronegativity means for example hydrogen chloride. Okay. So here the electronegativity is more for chloride. So the pair of electron, the shared pair of electron attract towards itself. தனக்கே எடுத்துக்கும். That is called as a electronegativity. Okay. What is my electronegativity? The shared pair of electrons towards itself. That is called as a electronegativity. So the alkali metals have comparatively smaller value of electronegativity than the other element in the respective period. Okay. So when they react with the other elements, they usually produce ionic compound. For example, they react with the halogen to form ionic halide. For example, sodium. The sodium react with the halogen. What is halogen? In a periodic table, the 17th group is called as a halogen. What are the and the group la என்னெல்லாம் இருக்கும் halogens என்னும்போது fluorine, chlorine, bromine, iodine, etc. Okay. So the fluorine, we take example fluorine. The sodiums react with the fluoride, we get sodium fluoride salt. Okay. Then hydrogen, the next lithium react with the fluoride, we get a lithium fluoride. Okay. Then next potassium react with the chlorine. Potassium means K, react with the chlorine, we get potassium chloride. So it is it can be dissociated, K getting positive charge, Cl getting minus charge, then sodium getting positive charge, fluorine getting minus charge. So it is a plus and minus represent the ionic. So it is called as a halide, so it is called as a ionic halide. Okay. The next topic is flame color and the spectra. What is the flame color and the spectra? When the alkali metal salts are moistured with the concentrated hydrochloride salt heated on a platinum wire, in a flame. If they show characteristic color, flame as shown below. So the flame color and wavelength are here, listed here. Lithium, the lithium is a crimson red color, the wavelength is 67.8. The sodium is a yellow color, the potassium is a violet color, the rubidium is a reddish violet color, the cesium is a blue color. Okay. So here the wavelength of the alkali metals listed here. Okay. So the heat in the flame excited the valence electron to higher energy level when it drop back to the actual energy level, the excess energy is emitted as a light whose wavelength is a visible region shown in that above table. That is, so இப்போ பார்த்தீங்கன்னா heat in the flame excited in the valence electron to the higher energy level. ஸோ இப்போ பார்த்தீங்கன்னா இப்போ எனர்ஜி லெவல் இப்படி இருக்குது. ஸோ the heat நம்ம ஹீட் பண்ணும்போது அந்த ஃப்ளேம் எல்லாமே பார்த்தீங்கன்னா அந்த வேலன்ஸ் எலக்ட்ரான்ஸ் எல்லாமே நமக்கு எக்ஸைட்டட் லெவல் ஹையர் எனர்ஜி லெவலுக்கு போகுது. ஹையர் எனர்ஜி லெவலுக்கு போயிட்டு when it drop back to the actual energy level, திருப்பி again என்ன வருதுனாக்கா drop back to the actual energy level. ஸோ ஆக்சுவல் எனர்ஜி லெவல் இருக்கும்போது மேலே போயிட்டு அதாவது ஹையர் எனர்ஜி லெவல் போயிட்டு கம்பேர் டு த லோயர் லெவல் வரும்போது ஸோ அதோட இங்கே ரிமைனிங் இருக்கிற அந்த எனர்ஜி எல்லாமே என்னவா எமிட் பண்ணுனாக்கா லைட்டாக நமக்கு எமிட் பண்ணிடும் அப்படின்றத நமக்கு சொல்கிறாங்க. ஓகே, ஸோ த வேவ்லென்த் இஸ் a visible region shown in the above table. So this is a sodium, the yellow color, the lithium, crimson red, then potash, lilac color. Okay, the next topic is distinctive behavior of lithium. Okay, the distinctive behavior of the lithium Li3 plus is due to the especially small size lithium. We know already the size of the lithium is so small, that why it is a solubility is a more அப்படின்றத நம்ம பார்த்தோம். So the small size, high polarizing power, high hydration energy, தண்ணியில் கரையுது நம்ம சொல்லுவோம் high hydration energy, and non availability of d orbital, because what is the lithium atomic number? Li is atomic number is 3, so is a 1s2 2s1 is a non availability of the d orbital. Okay, then comparison of properties of lithium with the other element of the groups. Okay, so the lithium and remaining group of the family. Okay, so the lithium is a hot and high melting point and boiling point. Then the other elements soft and lower melting point and a boiling point. அதாவது ரொம்ப கம்மியான மெல்டிங் பாயிண்ட்லேயே வந்து மற்றெல்லாம் பாயிலிங் பாயிண்ட்லேயே இதுவாகிடும். ஆனால் லித்தியம் பார்த்தீங்கன்னா மெல்டிங் அண்ட் பாயிலிங் பாயிண்ட் ரொம்ப அதிகமாக இருக்கும்ன்றாங்க. The next one, the least reactive. For example, it react with oxygen. Lithium is react with oxygen to form normal oxide, form peroxide. With a great difficult, higher oxides are unstable இருக்கும். Compared to the other element of the family, lithium பார்த்தீங்கன்னா react with oxygen கூட பண்ணுவோம் to form normal oxide, form peroxide. With a great difficult, higher oxide form ஆச்சுன்னா அது unstable இருக்கும்ன்றாங்க. Compared to the other element of the family, more reactive. Okay, the next react with the nitrogen to give the lithium is react with the nitrogen to give lithium nitride. Okay, then 6 lithium plus nitrogen we get a lithium nitrate. But other element of the family, the no reaction with the nitride. The next, lithium react with the bromine slowly. Lithium react with the bromine to form lithium bromide. Is a reaction is a very slow process. Then compared to the other family of the react violently. Okay, the next, the react directly. Lithium react directly with the carbon. Lithium react directly with the carbon to form ionic carbide. Ionic carbon, lithium getting positive. Okay, so this is called as a ionic carbon getting minus, so it is ionic carbide. The next, the do not react with the carbon directly but can react with the carbon compounds. So look at this, the lithium react with the directly with the carbon, but here lithium react directly, does not react with the directly, it react with the carbon compound. This is a ethane. Okay, so it react with the carbon compounds react on direct carbon kuda adu react agadu. The last one, the compounds are strongly soluble in water. Strongly, we know strongly soluble. This is highly soluble in water. Okay, these are the lithium nitrate decomposed to give oxide, decomposed to give nitrates. Okay, the properties of lithium with other element of the group. The next topic is similarities between lithium and magnesium. Similarities between lithium and magnesium. Okay, first properties. The lithium and magnesium are harder than other element in the respective groups. So அந்த குரூப்லேயே lithium magnesium வந்து கம்பேர் பண்ணும்போது ஹார்டராக இருக்கும்ன்றாங்க. The next, lithium and magnesium react slowly with water. The oxide and hydroxide are much less soluble. The hydroxide decompose on heating. So slowly react with water. Oxide and hydroxide வந்து much less soluble இருக்கும். Hydroxide வந்து decompose on heating. both form nitride. Lithium and magnesium form nitride by direct combination with the nitrogen. Similarities, okay, lithium and magnesium similarities. Then fourth point, they do not give any superoxide and form only oxide. So இது எந்த சூப்பர் ஆக்சைடு ஃபார்ம் ஆகுது, இது ஃபார்ம் ஒன்லினாக்கா ஆக்சைடு, லித்தியம் ஆக்சைடு அண்ட் மெக்னீஷியம் ஆக்சைடு. The lithium and magnesium do not form bicarbonate CO3 அது மாதிரி ஃபார்ம் பண்ணாது அப்படின்றாங்க. Then both lithium chloride and magnesium chloride soluble ethanol எதில் கரையுன்றாங்க, ethanol and electrons the crystalline form aqueous solution as either lithium chloride water and magnesium chloride water. Okay, then next topic is diagonal relationship. So diagonal relationship means already we studied in periodic classification lesson. So lithium, sodium, potassium, rubidium. Here is the beryllium, magnesium, calcium. The lithium ko magnesium ko ulla relationship is called as a diagonal. Then sodium and calcium ko diagonal. This is called as a diagonal relationship. Okay. So the similarity between first member group of lithium that is Li as a diagonally placed in the second element group of magnesium. So lithium is the first element group, then second element group is start with the beryllium, the lithium, sodium, here beryllium, magnesium. So the diagonal relationship between lithium and magnesium as a diagonal relationship. Okay, this is a first group, this one is a second group. Then it is due to the similar size, lithium 0.766 angstrom, magnesium 0.72 angstrom. So the comparable electronegative values, lithium 1.0, magnesium 1.2. Okay, so the next topic is chemical properties of alkali metals. Chemical properties of alkali metal. So the alkali metal exhibit high chemical reactivity. Alkali metals react with the high electronegativity element, so it is called as a highly reactivity. So alkali metals வந்து electronegative கூட elements கூட வந்து react பண்ணும் ரொம்ப அதிகமா, so it is called as a highly reactive. The next, the reactivity of alkali metal increases, and the reactivity compare பண்ணிங்கனாக்கா as we start with the lithium to end with the cesium ரொம்ப அதிகமா இருக்கும், that is increases. Since the ionization energy, so அப்போ ionization energy decreases ஆகும். So the alkali metal ஓட reactivity as we move down the group increases, the ionization energy as move down the group decreases. Okay, so all alkali metals are highly reactive to the more electronegative elements such as oxygen and halogen. More negative elements means oxygen, halogen say more negative element. Some characteristics of chemical properties of alkali metals are described below. So first one, reaction with the oxygen. All the alkali metal and exposure to air or oxygen burn vigorously, forming oxide on the surface. So lithium form only monoxide, sodium form monoxide and peroxide. Other elements from the monoxide, peroxide, superoxide. So these oxides are basic in nature. So lithium பார்த்தீங்கன்னாக்கா simple oxide தான் form ஆகும், but sodium பார்த்தீங்கன்னா peroxide, then make other oxide that is potassium, rubidium, cesium, it form superoxide. So these oxides are basic in nature. Give the examples are there. So lithium react with the oxygen to form Li2O, that is simple oxide. Simple oxide means it contains only one oxygen. Okay, here the sodium react with the oxygen to form Na2O2. O2 means it contains two oxygen, so it is called as a peroxide. The third one, M plus O2. M means it potassium, rubidium or cesium react with the oxygen to form O2. Okay, so the MO2 is called as a superoxide. So lithium, simple oxide, sodium, peroxide, then other metals are gives superoxide. Okay, the next topic is reaction. Next chemical properties, reaction with the hydrogen. All alkali metals react with the hydrogen at about 673 Kelvin. So lithium at 1073 Kelvin, because already we discussed about the physical properties of alkali metal. All alkali metals react with hydrogen at about 673 Kelvin, whereas lithium react with 1073 Kelvin to form corresponding ionic hydrides. So the reactivity of alkali metal with the hydrogen decrease from lithium to cesium. So the M is a metal, react with the hydrogen to form M plus and H minus. The M is a metal, H is a, so the M is a metal, react with the hydrogen to form M plus H minus. So the M is a lithium, sodium, potassium, rubidium, cesium. So the ionic character of hydrates increase from lithium to cesium. The ionic characters are increases. So the stability decreases. The hydrates becomes a strong reducing agent and the reducing nature increases down the group. So down the group means lithium to cesium, the reducing natures are increasing. Okay. Then next topic is reaction with the halogen. So the alkali metals react with the halogen. Halogen means fluorine, chlorine, bromine, iodine is called as a halogen. Okay. So the reaction with the halogen to form metal halides. So the M is a metal, react with the halogen to form metal halides. So all metal halides are ionic crystal because it plus and minus, so it is called as a ionic crystal. However, lithium iodide shows the covalent character as the smallest cation, the exact higher polarizing power of the iodide ion. So lithium iodide means Li so it is a smallest cation because the size of the cation is small. So it's the high polarizing power of the iodine ion. So the additionally the iodine ion being the largest can be polarized to greater extent by Li plus. Then reaction with the liquid ammonia. The alkali metal dissolve in liquid ammonia to give deep blue solution. They are conducting in nature. The specific conductor of mercury is 10 power 4 ohms. The sodium of liquid ammonia 0.5 10 power 4 ohms. So this happens, the alkali metals atom really lose its valence electron ammonia solution. Both the cation and electrons are ammoniated to give ammoniated cation and ammoniated electrons. So M plus XY NH3 gives us MNH3 plus and ENH3Y. Okay. So the blue color of the solution, the ammoniated electron absorb the energy in the visible region. We already saw the excited state to electrons வந்து மேலே போயிட்டு திரும்ப வரும்போது அந்த excess energy எல்லாம் emit பண்ணும் already நம்ம பார்த்தோம். So the input the blue color of the solution, this shows a paramagnetic and the standing slow liberate hydrogen resulting the formation of amide. That is M plus E gives us NH3 plus of hydrogen. Okay. In concentrated solution, blue color changes into the bronze color and becomes diamagnetic. In dilute solution is a paramagnetic, so concentrated solution is a diamagnetic. The next topic is reaction with water. So lithium is react with water, that is a lithium hydroxide. We already discussed about the alkali metals to form oxide and hydroxide. So this is a hydroxide. Lithium react with water to form lithium hydroxide. It also react with the alcohol. It also react with the alkynes. Okay, the sodium react with the alcohol. We form sodium ethoxide. So the next is a reducing activity. Next topic is a reducing activity. Alkali metal can lose the valence electron really and act as a good reducing agent. We know lithium is a Li plus 3. That is lithium is atomic number 3. It lose one valence electron, it getting Li plus. So it act as a good reducing agent. Okay. The next reaction with the carbon. Lithium directly react with the carbon. We already discussed about the properties of lithium and other family. So lithium react with the carbon to form ionic compound. For example, lithium carbide Li plus and C minus. So other element do not react with the carbon directly. It is react with the compounds of carbon. We already discussed about the properties of lithium and other elements of the group. The lithium react with the carbon to form ionic carbide, whereas other element do not react with the carbon directly but can react with the carbon compounds. Okay. The last one is uses of alkali metal. So the alkali metal uses, the first one is a lithium metal. Here the 7 uses are there. It may be asked in 2 mark or 3 mark. You can write at least 3. Okay. So the first uses, lithium metal is used to make useful alloys. For example, if the lead is used to make white metal bearings for motor engine, aluminum making aircraft parts. So the magnesium to make armor plus the போர் காலத்துல தான் கேடை மாதிரிலாம் வச்சிருப்பாங்களே அது. It is used as a thermonuclear reactions. The lithium is also used to making electrochemical cells use பண்றாங்க. The lithium carbon is used for a medicine purpose. Then sodium is used to make sodium and lead alloy needed to make lead ethylene tetraethylene, the lead methyl tetramethylene. So இந்த organolead compounds எங்கெல்லாம் யூஸ் பண்ணுறாங்கன்னா இந்த ஆன்டி நாக் அடிட்டிவ் பெட்ரோலில் நவடேஸில் ஃப்ரீ பெட்ரோலுக்காக நமக்கு யூஸ் பண்ணுறாங்க. ஓகே. The lithium sodium metal, so that is liquid sodium metal is used, the coolant use பண்றாங்க ஒரு fast breeder nuclear reactorல. Then potassium we know the vital role in biological system. Then cesium is used the devising the hydro for that is photoelectric cells. Okay, so these are the uses of alkali metal. Students, I hope you understand the concept. Please watch the link and do the assignment. Okay, thank you.